So today I'm going to start a new topic that is relativity. इस लेक्चर में मैं अंडर ग्रेजुएट लेवल के लिए में जो रिलेटिविटी यूज होती है आई एम गोइंग टू टॉक अबाउट दैट राइट सो हियर I will give a brief introduction to Galilean transformation. As students have already studied the Galilean transformation, but here I will give I want to briefly review this Galilean transformation. And another thing which I want to discuss here is that is very important that we have studied in at the +1 level that rest and motion are relative terms. Right, this is a very important point. And basically this is the beginning of relativity. Say if I try to look at this diagram. So in this diagram here I am observing that a boy is throwing a ball upward, right? And this ball comes downward. It goes up and then comes down. And when it is moving with velocity in this direction, and the person who is throwing this ball upward, for that person, this ball is again coming down into his hands again. Right? That means for the observer, if this person is the observer in this moving truck, then for this observer, it seems that ball is moving a vertical path, right? It moves upward and then comes downward into his hands. But during this journey, when this ball goes up and then comes down, during this journey, ball has covered or this vehicle has covered a distance. So that means if for an observer who is outside the truck and is a stationary observer, then it seems that this ball follows a parabolic path, right? Now observer is this, and in this case this is the observer, means observer is moving with the same velocity with which ball is moving. That means ball seems to be, means ball is not moving a horizontal distance, but for a person who is on the earth or at some place on the earth and it's a stationary, then it seems that the ball is following a parabolic path. So that is the this sentence or this line will become very much clear that rest and motion are the relative terms, because along horizontally it is not traveling any distance, but here it seems that it is traveling some distance horizontally. So that means for a person in this moving truck, the horizontal distance traveled will be 0, but for an observer who is on the truck, who is outside the truck and is stationary, it seems that ball is moving some horizontal distance and it's like a parabola. So that means there are two types of frame of references, means one frame of reference is stationary and another frame of reference which I am choosing or considering another frame of reference that is moving with some uniform velocity. And if we are observing some point object or something from these two different frame of reference, then things seem to be different. Then how these two frame of reference is related to each other, how coordinates seems to be different, that's what are the Galilean transformations. So Galilean transformations are also called Galilean transformations are also called Newtonian transformation, means these were Galilean transformations were set of equations in classical physics which relate space and time coordinates of two systems and as I'm saying that which relates space and time, that means when we are talking about a coordinate system in which we are talking about both space and time, then such systems are known as frame of references. That means we are having two types of frame of references. In which one is moving with a constant velocity. Constant velocity related to each other or relative to each other. That is, in simple language, one can say that one frame of reference at rest and other frame of reference moving with v velocity or with uniform velocity v. So let us try to understand it diagrammatically, that what does it mean. So there is a particle which is located at this point, and here this is a clock c in this frame of reference, and there is a clock c prime, and say it is x-axis or it is x prime, and it is y prime, and it is z prime, and it is it is x. Just a minute, let me correct it. Yeah, it is x-axis, it is y prime, it is z prime, and it is z, and it is y, right? So these are the two frame of references, and these two frame of references measuring both space and time, and this is the position vector of some particle when observed from the S frame of reference. Let me call this as S frame of reference. This is the S frame of reference. This is S frame of reference, and say it is S prime frame of reference. And this frame of reference is moving with velocity v along this direction. And when seen from this frame of reference, moving frame of reference, its position vector will become, in one frame of reference, its position vector is x, y, z, t. It is x, y, z, and t when observed from observed from stationary frame of reference, and when observed from moving frame of reference, then it seems that it is x prime, y prime, and z prime, and t prime when observed from the moving frame of reference, and it is moving with velocity v along this direction. Now, this frame of reference, initially both the frame of references are coinciding, but with the passage of time it travels a distance this distance, and if it is moving with velocity v, then during in time t, this moving frame of reference travels this distance pt. So that means I can write down from geometry that x prime is equal to x minus bt, y prime will remain y, z prime will remain z, and t prime will remain t. So these are known as Galilean transformation. But if I take derivative on both sides, then it will become Vx prime must be equal to Vx minus P, and Vy prime is equal to Vy, and Vz prime is equal to Vz. These are also known as Galilean transformation, but for the velocity, right? Now, let me come back again to this diagram. That means when I am observing the ball from the stationary frame of reference, it seems that it follows a parabolic trajectory. So let us try to understand that how this looks like when we are using the Galilean transformation, whether this answer this question or not, right? So that is the best way to appreciate the Galilean transformation. So as I know that Vx prime is equal to Vx minus V, from here I can write down Vx is equal to Vx prime plus P. So what is Vx? Vx is the velocity of the ball along x-axis when seen from rest or stationary frame of reference, right? And what is Vx prime? Vx prime is the velocity of the ball when seen from velocity of the ball what along x-axis when seen from moving frame of reference. Means when we are looking at it from the moving track, then Vx prime seems to be 0. but it seems to be at rest along x-axis because it is not moving along x-axis. That means if s prime frame of reference is moving with velocity v, then vx is nothing but it is equal to 0 plus v, so it is equal to v. So this is the velocity with which ball is moving for the stationary frame of reference. Now let me go to the next part. As I know that Vy is equal to Vy prime, but ball is thrown vertically upward. When ball is thrown vertically upward, it travels some horizontal and the vertical distance, but from the moving frame of reference, its horizontal distance will be 0. There is no horizontal distance. But when seen from the rest, then there is some horizontal displacement, and when seen from rest frame of reference, then x seems to be like this vxt. It is the horizontal distance, velocity into time. Also y, and it is moving under the effect of gravity, so it is v by t minus half gt square. But if I use this here, then t comes out to be x over vx, and if I put its value here, x over vx, and it is nothing but x over v from here, right? Then y comes out to be vy, it is x over v minus half g x over v square. So that means I can write down y is equal to vy x vy over v into x minus g over 2v square x square. So it's like a equation of parabola. It's like a equation of parabola. So that means when ball is observed, it means, what does it mean? It means that when ball is observed by an observer on the ground, then it seems that then its trajectory seems like trajectory of parabola. And thus these frame of references, thus Galilean transformations help us to understand that how ball seems to be like, right? That's all for this lecture, and in the next lecture I will talk about that Galilean transformation leads to the Lorentz transformation and the special theory of relativity, and that's a very interesting lecture.